Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Thank you for joining the second UNIKOM Light Series event. Allow me to introduce myself. My name is Hanhan Maulana. I will guide today's guest lecture event. For your information, UNIKOM Light Series is held twice a month. Once with non-technical theme and once with technical theme. So today Light Series takes the theme of similarity measure and data analysis. And for today's speaker is Professor Hamid Hasanpour, Ph.D. from Sharrood University, Iran. So allow me to read his CP. Professor Hamid Hasanpour is get his bachelor degree in Iran University of Science and Technology, Tehran, Iran, in 1993, with the project title Designing a 24-bit microprocessor using microprogramming. And then he get master degree from Amir Kabir University of Technology, also in Tehran, Iran, in 1996. And then he got doctoral degree from Queensland University of Technology, Brisbane, Australia in 2004. So actually, Professor Hamid have some technical area of interest. His interest in data mining, biomedical signal processing, time frequency signal processing and analysis, text syntax analyzing, image processing, and artificial neural network. He also has so many honor and awards. One of his awards is Distinguished Professor of the Year in Research, Faculty of Computer Engineering and IT, Sharrood University of Technology, Iran, from 2009 until 2021. So before Professor Hamid start the presentation, I inform the audience that the attendance sheet for today's activity would be given after Professor Hamid presentation is over. And Professor Hamid is already joined with us. If I didn't wrong, this is 10 a.m. in Iran, Professor. Assalamualaikum.
Assalamu alaikum, brothers and sisters. Bismillah ar-Rahman ar-Rahim. Yeah.
Okay. Professor, time is yours.
Okay. Thank you, Dr. Hanhan Maulana. And thank you for providing me this opportunity to have another presentation with the UNIKOM University. Assalamu alaikum, brothers and sisters, and good afternoon, everyone, from a morning in Iran. Let me share my presentation here. Do you have the presentation file here now? Can you see? Okay. Today, we have a subject on similarity measure and data analysis, which is an important subject in engineering. As an introduction, I have a brief preface about the subject. Suppose that you have two sequences, A and B, each of which representing fluctuations of a pattern, for example, a stock market or fluctuations of temperature in two different places. And for an application, you need to compare the fluctuations of the two sequences for any decision. Then we use a function as a similarity function to compare the two sequences and given a score. If the score is higher than the threshold, you may decide to do an action. So this is the job of a similarity measure, which has application in many areas, from pattern recognition, data analysis, image processing. For example, if you want to compare the faces of people or fingerprints of people, plenty of application in document classification, in recommender systems. And anymore, for example, in economic science, even suppose that you want to find companies with similar stock prices over a time interval, or you want to find a product with similar sales cycles. And another application, suppose that you have a product to sell and a customer requests a product, for example, a PC. Then you may not have that product in stock. Then you need to offer the one that is more similar to the request of the customer. So in this case, we can see that we need a similarity measure. This is the reason that I say here that in almost every engineering application, especially in data mining, a similarity measure or distance measure, which is called sometimes distance measure, is involved. So we need to have good knowledge about similarity measure as an engineer. So in similarity measure, there are two important issues to consider. Suppose that we want to compare patterns. We can compare the raw data, the raw patterns. Say, for example, you want to compare the logo of a mosque to the one that you have in the database, and to make a decision whether the logo is for a mosque or for example, for Quran. Then you can, as I said, you can compare the raw data, but comparing the raw data would be very difficult and sometimes may not be effective, because two patterns may have different colors, different orientation, different sizes, and even different style. Here you can see the logo of mosque, but they are not exactly the same, but we can understand they are very similar. So in this case, that we say that in engineering, we prefer to have feature selection depending on the context to better represent the pattern and to make a decision. So as I said, comparing raw data would not often effective. So we need to have feature selection. I will have a brief discussion about how to have a feature selection in an application. And the other important issue is about measure selection. So we need to have a criteria to make a decision about the patterns. So in measure selection, so we need to have some knowledge about data specification and the measure that the capability of the measure that we will discuss today. Now here, suppose that we have various patterns and you want to classify them. You can see we have different patterns, but the question is, what's the purpose? What's the context? We can classify these patterns in terms of shape, in terms of color, in terms of size, in terms of pattern. So you can see that you may have different results for different contexts, for distant purpose of your classification. So here we can say that if you want to consider shape, so we need a feature. If we want to consider color, we need another feature. So this is the reason that we say feature selection is an important issue in similarity evaluation. And of course, selection of features is related to the utility and the application that we are using. Suppose that we want to have a pattern recognition for example, to recognize different digits. So as you can see, digits are in different sizes, different style, different fonts. It would be very difficult to compare raw data to recognize a digit, for example, 5, to which one is 5. So in this case, we need to have a feature selection first. Here, I will show you a simple techniques of feature selection for patterns like digits. So now here you have a pattern like in binary forms in black and white. For digit 7, you can see the 0 area is the background, the 1's area representing the digit. You can see the 7 here. So in this case, if we want to extract a feature, there are different ways. One of the ways that we can consider is to have a summation from the columns and also from the rows, and each summation from the column give us a number. Here, for example, give us a number, we put it here, another one here. Okay, so then we would have we can convert the image or the pattern to a vector. Here you can see the features from summation from the from each in the single columns, and the other one from each single rows, and then we concatenate it together to make a pattern, to make a signature, or to make a feature for the pattern we are trying to analyze. So here is the pattern. Then we can use it for any process. This is the way that OCR system, I mean optical character recognition system, used to recognize digits. Here you can see that we use the same ways to extract features from various digits from 0 to 9 in different fonts. So as you can see, digit 0 in different fonts, they are all similar, and they are dissimilar to digits in other groups. And as you can see here, they are not exactly the same, but they are similar. In this case, we need to have a similarity measure to recognize a digit. So say, for example, we have a digit like 5, and then we want to make sure that what's the digit. First, we extract a feature and compare just the feature. I mean, the two sequences A and B using the similarity measure. Okay. Here you can see that we use feature for number 2, for digit number 2, in 2 different fonts. As you can see, you know, you have a little bit different appearance, different values in different position, as you can see here. If in this case, if we want to use measure like a Euclidean distance, then it doesn't work. We can, using the Euclidean distance, we cannot say that this pattern is the same as the other pattern. Then in this case, we need to be aware about similarity measure, the capability of various similarity measure. We need to be aware about the existence of various similarity measure. Here, I introduce you some existing similarity measures. Definitely, you are aware about some of them. For example, about the Euclidean distance, Manhattan distance, Minkowski distance. I will not explain about the individual similarity measure. Of course, you are aware about them, or you are not aware about them. You can, about some of them, you may refer to references and have more knowledge about their capability. Now, here we are saying that different similarity measure have different capability, and we need to be aware about the capability of different similarity measure. And for an application, we need to have a correct decision about choosing the right similarity measure. Here you can see some other similarity measure like cosine, correlation, and Jensen similarity measure. And of course, there are plenty of other similarity measure that can be considered. So as I said, each similarity measure has its own interpretation on data spatially. And this is one important issue. The other important issue is that there's sensitivity against shifting, scaling in time or amplitude in two different axes. I mean, from time or to amplitude, they are not the same. Their sensitivity is different, and we need to be aware. Now, here you have a pattern, different patterns of different various digits. So as you can see here, you can see, for example, number 1, number 2, there are different appearances. And if you extract features the same way that we did in our previous slides, you can see, you can understand that they have different features, and then how similarity measure can be able to recognize similar or the same digits in different fonts in different style. This is the way that many of optical character systems taking into account, and almost all OCR systems are font dependent. You cannot find an OCR system that could be able to recognize all existing fonts for various patterns or various script. If you provide an optical recognition system in the catalog, you will see that this OCR is able to recognize such fonts. So this means that they are using they are using some similarity measure with a capability. Those you cannot expect any similarity measure to be able to recognize all difficulties that may exist in a pattern. Hence, you need to have insight into similarity measure role in classification that will be discussed here. Here you have suppose we have an original pattern or signal here, and all of these signal or patterns are similar, but with different disturbance. Here you have a noise with the signal, and here the signal or the pattern was shifted in amplitude, and here the pattern was shifted in time, and the other one scaled in amplitude, and the other one scaled in time. So as I said, it happened in our application, for example, in digit recognition, in voice recognition, and many other applications. And the other specification that we need to discuss is about time delay and phase delay. Now, in our previous, I explained to you about time shifted or time delay, and now sometimes we may also have phase delay. Phase delay is something else. I explained here in this image that in time delay, the exact pattern is a start with a delay, let's say few seconds. But in phase delay, different place of the pattern is started and then is continued. Still, we can say that the patterns are similar, but with different phase delay. So here we need to have insight about the properties of various similarity measure. I summarize the properties of few similarity measure here. For example, distance measures, for example, Euclidean distance measure is not able to handle time shift, amplitude shift, time scale, amplitude scale, phase delay. What does that mean? That means that if you have an application that the features of different patterns from the same group have time shift or amplitude shift, then the Euclidean distance or any distance measure is not able to handle similar patterns. Okay, here I have some other similarity measure like normalized Euclidean distance, chi-square, Jensen, cosine, and correlation. the normal Euclidean distance, it can handle amplitude shift and amplitude scale, but is not able to handle phase delay or time shift. And from this group, you can see that Jensen and cosine similarity measure is able to handle amplitude scale. In amplitude scale, I may pronounce a word like Ali. Then later, Ali is louder. In this case, the two different patterns would have different amplitude, is scaled in terms of amplitude. So in this case, we cannot say that correlation function or any similarity measure using Euclidean distance is able to handle the patterns. But similarity measure like Jensen and cosine is able to handle. So we need to be, as I said, to be aware about the properties and capabilities of different similarity measure in terms of handling different situations that we may have in features of patterns. This is one important issue. And the other important issue is that here you can see that cosine and Jensen and also normalized Euclidean distance, all of the three are able to handle amplitude scale. And suppose that in an application, the features are disturbed in amplitude. I mean, amplitude scale is involved. The question is that whether they are the same. It doesn't matter whether we want to choose cosine or Jensen or normalize Euclidean distance for the application. Definitely, the answer is not yes. The answer would be no, because different similarity measure has different geometric view on our data. For example, here you can see that two different functions. The function like xi, we have a vector like x. And the S1 is xi divided by the normalized norm of x, and the other one sine xi. Both of them are applied on the data. The data is x, but the first one, and both of them are fluctuated between -1 and 1. But definitely they are not the same for different data. So if data is changed, definitely S1 and S2 will not have the same effect. But for some data, they may have the same result. For example, if x1 is 0, S1 and S2, both of them would be 0, because sine for 0 is 0, and S1 0 divided by everything would be 0. But for different other values, they may not have the same output. So here is the reason that I say, even if two different similarity measures have the same properties in terms of, for example, amplitude scale, we need to be aware about the geometric views of the similarity measure and then choose a right one. Now, even for an application, the existing similarity measure may not be able to handle, then what should we do? First, as I said, we need to be aware about the capability of different similarity measures. And if for our application, some of the existing similarity measure or none of the existing similarity measure can handle the situation, then we may develop a new similarity measure. We develop our own similarity measure for the application. Then the question is, what's the general specification of a similarity measure? Here I explain the general specification of a similarity measure. Here, we say that it should satisfy the following criteria. For example, the positivity. If the similarity measure is D and want to evaluate the similarity between two sequences X and Y, definitely the values should be a positive value. It doesn't mean that if the similarity measure is between -1 and 1, it is not able to be used in an application. No, but we prefer to have the measure to be positive, because sometimes if we want to use a pattern in a similar group, positivity will have a better view about the results. And the other thing is about the symmetry. And the other things about the triangle inequality, which means that if X and Y, if we compare the similarity between X and Y and the similarity between X and Z and Y and Z, then the similarity between X and Z should be less or equal than the similarity between X and Y and Z. But as I said, some similarity measure may not have the value between 0 and 1, but it would be good to have the value between 0 and 1, because if you compare two sequences and the sequence is, for example, 100, what does that mean? How can it tell us that how similar are the two sequences? But if a similarity measure like a Jensen similarity measure can give us output between 0 and 1, and the comparison results are near to 1 or near to 0, we can make a decision about the sequences, whether they are similar or dissimilar. And the other advanced issue in similarity measure is about pre-processing the data. And the other things is about part-based similarity that which we'll discuss here. For data pre-processing, sometimes we need to apply transformation on data. I will show you in the next slide. And also, the data may have noise, so we prefer to remove the noise first, then try to compare the sequences. And another important issue is about time warping, which has very good application in some areas we'll discuss here. Now about the transformation. Suppose that we have sequences of ECG. So here you have sequences of ECG signal, and say you want to compare the sequences. As you can say, the ECG signal is now, you can see a spike in consequences, and for any reason you may need to compare the successive impulses and to make any decision or to recommend the person about the situation of the person. Here in this case, you can see that some patterns have no offset. In this case, we need to remove the offset. So one of the important transformations is offset removing. So if you remove the offset, then you can compare them. Here, if you compare this one and the other one at the absolute value, you cannot handle that. The two patterns here and that one are the same. But if you remove the offset or a DC value, which is the results of breathing, once people breathing, they have fluctuation. So this offset is due to the breathing. So once we remove the fluctuation, then we can compare that you can see here. And another transformation that we may need is about amplitude scaling. So you can see two sequences with different amplitude scaling. So we need to normalize the scaling and then compare them. So say, for example, you want to the pulse from the rest and compare the results. So once the person is walking, is resting, the fluctuation and the amplitude of fluctuation may not be the same. So in this case, we need to consider amplitude scaling, and after that, we can compare the pulse. As another transformation that we may need often is linear trend, removing the linear trend. So here, suppose that you have the sequences of two different markets which have similar patterns. So here you have two different sequences from two different markets. They are similar, but one of them is increasing, but the other one is the fluctuation is in a straight line. So in this case, if we want to compare the two sequences, first we need to remove the linear trend here, and after that, possibly we need to remove the offset and finally, we remove the amplitude scale and then compare the two sequences. And you can see that the two sequences are very similar, but we could not find the the two sequences are similar from the original signal. Yeah, so here we can see that if we do the transformation like linear trend, removing an offset translation, removing and also amplitude scaling, we can see that two sequences are very similar. Of course, after that, we need to have a right similarity measure to be able to consider two sequences to be similar. And another transformation that we may need is about noise removing. So you can see the two sequences cannot be similar using a similarity measure. So then if we somehow smooth the signal, then we will be able to recognize the two sequences to be very similar. And as I said about other property that sometimes the similarity measure need to be taken into account is about time warping. Here the two sequences are very similar, you can see that, but the bottom one is stretched, although both of them are similar, but the bottom one is not exactly the same point by point. If you consider the two sequences point by point, you cannot find any similarity between them. But if you apply time warping match, so this sequence here, the other sequence, you see, and sometimes a sample may be repeated, from if this is the original one and the one is the one that is stretched. So we can see that one sample is mapped on few samples of destination. This is the one that time warping is doing. So in this case, we need to find initially an optimal alignment between the two sequences and then doing the warping. Warping means that the sample in source may be repeated several times in destination. Suppose that, for example, someone is talking and announcing a word like Ali, Ali. So both of them are the same, but stretched in the second pronouncing. So in this case, we need a time warping to be able to match the two sequences. So as I said, it has very, dynamic time warping has very good application in signal processing, especially in speech recognition, to recognize the different words, because words, as I given you some example like Ali and Ali, may have a different acceleration or deceleration along the time, so the dynamic time warping can handle the situation. And the basic idea behind the dynamic time warping is that if we have two sequences X and Y, even the two sequences may not be the same lengths. Here in this example, both of them are the same lengths, but it doesn't matter. They can be different lengths. If they are in different lengths, then we are allowed to extend each sequences by repeating elements. And once we extend a sequence, we extended a sequence by repeating elements. And then after that, we can use a similarity measure, for example, Euclidean distance, to compare between the two extended sequences and make any decision. So if we have two sequences X and Y, and we want to compare them, the comparison of the two signals would be like, would be a line, a straight line, depending the correlation, the angle would be lower or higher. But anyway, if the two sequences are correlated, I mean they are similar, because correlation is one of similarity measure. If the two signals or two patterns are similar, and we plot one against the other, X is the first one and X and Y is the second one, then we will have a straight line. But if the two sequences are still similar, but with different lengths, we may have a pattern like this. Here it means that few samples from X are repeated in Y, are similarly repeated in Y. And here is saying that a sample in Y is similarly repeated in X. So this is the meaning. So this is the meaning of dynamic time warping that I explained here. So once you have a plot of dynamic time warping, we can see that there is some restrictions on a warping path. The restriction is that the monotonicity, which means that the paths go up, not go down or to left, up or right. So from here you can see up and right, up and somehow right, not down or left. So and also the path is continuous, not discrete. So you could see from the example. And the other important issue, the warping window. I mean, the window, let me show it here. You know, the warping window, here is our window. Between the two dashed lines is the window width. So the warping window is another restriction, depending, you know, you want to apply the restriction on the similarity of the two patterns. And if we want to consider formulation for dynamic time warping, say we have two sequences of X and Y with different lengths, and D referring to the dynamic time warping distance between the two sequences. Then to compute the distance, if this is the similarity measure, so here I say the absolute value xi minus yj, it's representing the similarity measure. So if the similarity measure is cosine, you can use cosine similarity measure. If the similarity measure is Minkowski or Euclidean distance, you can use Euclidean distance here. So depending, so you can, as I said, apply dynamic time warping to any similarity measure. So here is depending the similarity measure formula, and then here representing the window size, saying the minimum value of I minus 1 and j, I minus 1, j minus 1, I and j minus 1. So here the window size is is 1. So if the window size is larger, so other attribute also would be involved in this computation. I mean, the I minus 2 and j, the I minus 3 and j, so depending to the window length. So that way you can compute the time warping for any computation. Now about another important issue is about geospatial entity of features. Suppose that you want to compare faces of people. Not only time scale, time shift, amplitude scale, amplitude shift are important issue to consider here. Another important issue is that you may extract different features from different areas, features from eye, from eyebrow, from hair, from chin, from nose, from lip. So you have different features, and different feature does not have the same importance in our recognition, because you cannot expect that hairstyle of people are all the same in all the time. Hairstyle may be changed. So we need to have, if for example, if you want to compare the two faces C1 and C2, and SPSF and SA representing features extracted from different areas, and each area depending to the importance of in recognition, we apply a coefficient for the feature. So here we say that in some application, we may not use the raw features apply to a similarity measure. After that, we need to apply a coefficient to features applied to a similarity measure to different area. Even we may use different similarity measure for different area. I mean, if you want to have a face recognition, one similarity measure for eye, another similarity measure maybe for chin, another similarity measure for eyebrow. But we prefer not to do like this. I mean, using different similarity measure for different area, but it may happen for some application, okay? And use different coefficient for different area. Okay, in conclusion, we can say that in similarity evaluation, feature extraction or feature selection has an important issue. If we want to have a good results in pattern matching, important issue is feature extraction, as we explained here in our presentation. And another important issue is about a specification of similarity pattern, whether the pattern have time shift, phase delay, noise, or something like that. So what the specification of your patterns in similar group? If patterns in similar group may have time shift or time scale, then use similarity measure that can handle the situation, the specification. And another remark would be about our knowledge to the sensitivity or ability of various similarity measure. Have you had some example here? And also about the power of data pre-processing in similarity measure performance. Thank you, everyone. And thank you, UNIKOM University, to providing me such opportunity to have another presentation to our colleagues at the UNIKOM University. Yeah, thank you.
Okay, thank you for fruitful and wonderful presentation, Professor.
My pleasure.
Okay, any question from the audience? For audience, you can use the raising hand feature, or you can also can write your question in chat. So please, everyone. Okay. When writing the question from the audience, Professor, I have one question. I think not question, but yeah, something like I want to ask some about the dynamic typing time wrapping. So yeah, I think it's perhaps the most popular measure of the distance for time series data, if I'm not wrong. So yeah, it captures the flexibility of similarity under time distortion, right?
Yeah, you know,
yes,
for some application, applying dynamic time warping is very important, but I can say that this is not applicable to any situation. For example, if you want to compare two patterns of digits, definitely time warping is not applicable. Will give you wrong results. But if you want to compare words or pronunciation of two words like Ali, then definitely you need to have time warping capability into account.
Yes. So I also read most of the research have some problem, like they have imposed rigid constraint on the band path. For example, I think how effective the restriction on the warping prompt for this situation?
Yeah, there are two important issues about using time warping. One is whether the application that we are using for time warping is applicable, and the other important issue is the window size. As I said, if you want to compare the two sequences like Ali and Ali, it is not common to say Ali, because if I want to stretch the word such a long, then you may recognize various words to be similar. This is the reason that I'm saying that in using dynamic time warping, the window length is important. So if you want to use it in speech recognition, you need to consider what is usual to extend or to scale a word in the speech.
Okay.
And so this means that we need to be careful about using the dynamic time warping in a similarity measure. We can apply dynamic time warping in any similarity measure, as I explained in one of my presentation, in one of my slides. So, but we need to be careful about the application.
Yes. Yeah. Okay, Professor. Actually, we have some direct message from the participant. So the question is, it is possible to use similarity measure outside of the engineering field? For example, similarity measure for business process model?
Yeah, definitely.
Something like that.
Yeah. So no, I am as an engineer could provide various examples from engineer, but definitely you may have the same. You may need to use similarity measure in different application, even in business application. So we can say that it has application in many different areas, but I, as an engineer, could provide some example from engineering application. Okay.
Another question. It's come from Indra Kurniawan. I will read the question, Professor. Hello, Professor Hasanpur. I am Indra from postgraduate department UNIKOM. I have a question. Is similarity measure used in manuscript plagiarism checker like Turnitin?
Manuscript checking, you say?
Yes.
Yeah, you know, even in manuscript checking or any pattern checking, we need to have a similarity measure in the engine. Sometimes, you know, people do plenty of pre-processing on the data so that the end data to be very simple. To what? To have very simple similarity measure like Euclidean distance to be applicable. Okay? But in many applications, we need to develop very complex system. We need to have very we need to have a right similarity measure to handle the complexity of the patterns like time shift, time scale, amplitude scale. If we choose a right similarity measure, then designing the system would be very simple. As I said, for OCR system, all OCR systems are sensitive to the font. You cannot find an OCR system to be able to recognize all fonts for any patterns, for any script. But if they can use a right similarity measure, then they would be able to handle all of the font. Even they would be able to recognize handwritten script. Okay, so we can say that if we have enough knowledge about similarity measure, it can give us the ability to develop the system very easily and have a very robust result.
Yes. And but I think it will be need large of the data, like.
Yeah, in our university, a few years ago, I introduced a subject for master thesis about similarity measure. So
Yes.
that means that has important area to work about the similarity. Still, some other student can work on the area of the similarity measure. Similarity measure is a wide area and has very good important application in different area, specifically in engineering application.
Yes. Another question. Oh,
Yeah.
Thank you for your answer, Professor Indra Kurniawan Said.
My pleasure. My pleasure.
Another question from Amar Ripkut Abrar. So the question is, are there any other method or variation of dynamic time wrapping that can be used to improve the efficiency or accuracy of similarity measurement?
Yeah. Now, in using dynamic time warping, it has very good application. And if you refer to literature, you can find plenty of techniques applied on dynamic time warping. And some people try to improve dynamic time warping in terms of the speed. The dynamic time warping is very slow, but there are some techniques to improve the speed and also to improve the capability of dynamic time warping. I also wrote a paper in International Journal of Electronics with my former master students, Ali Darvishi, which developed a new similarity measure. In the similarity measure, we use dynamic time warping, and we also apply some other transformation of data like noise removing, amplitude scaling, and something like that, and we develop a new similarity measure. Yeah, so it can be applicable, yes.
Okay, another question. It's come from Haikal Al-Ghifari. Hello, Professor. My name is Haikal, and I have a question for you. In time series analysis, dynamic time wrapping is one of the algorithms to measure the similarity between two temporal sequences whose speed may differ. Fast DTW is a faster method. I want to know how to implement this method not only between two signals, but three or more.
Yeah. If you want to compare the similarity between two or more, so we need to be sure that, we need to define a policy, whether all of the individual in the group want to be similar or not. No, usually in similarity measure, we use the measure to compare two sequences. And if we have more sequences, then we can cluster them, or we can subdivide them in a smaller group, and each group can be scored in terms of similarity. So if individual of them have similar behavior, then we can say that they are similar. But I guess the person that had raised the question has some important application which is related to similarity measure. Let me explain. Now, sometimes we want to recognize different patterns, but if you want to recognize different patterns, we need to have a sample pattern to compare all of them. Okay, say for example, we want to compare faces of people in different nations. Iranian nation, Indonesian nation. Iranian people are similar together. Indonesian people are similar together. So they are dissimilar from the two nations. Then we have a face. how I can say that the face is from Iran or is from Indonesia? This is another application area that we need to be discussing another time, inshallah. Okay, in this case, we should say that from all people in Iran, we need to have a representation. And so we should have the same case for people in Indonesia. I mean, and we need to have a representation from people in Indonesia. So from each cluster or from each nation, we need to have a representation. Representative. Then we will say that if we have a face, we will compare the face with the representation of the group or representation of the cluster. If the results saying that they are similar, then we can say that the face is from Indonesia or is from the Iran. Okay? Could I answer your question?
Okay, Haika, how about the answer?
Yeah.
Oh, that's pleasant answer, Professor. So
My pleasure.
I think that's
my
it.
pleasure.
Okay, there is a lot of question, Professor. This question is come from Mia Haulia. Hello, Professor. I am Mia Haulia from Informatics. I have a question. Is there any difference in doing similarity measure for various data type, such as nominal, ordinal, interval, and ratio?
I'm not sure whether there is a specific similarity measure to be able to handle those data. I mean, I'm not sure about a specific data. We need to be to analyze the data behavior of a data, then choose a right similarity measure. So I did some experience using similarity measure in different area, and I can say that in different area we need we need an issue of similarity measure and a single similarity measure, but sometimes we may not have similarity measure to be able to handle the data. Then we need to develop our own similarity measure for our own data. Okay, for that application that has been asked by the participant, I'm not aware that whether there is a similarity measure that can easily handle the situation. But if it's important for the participant can send me some data and share with me the data, then I can give the participant my suggestion which similarity measure can be useful.
Okay.
My pleasure.
There is another question for Mia. Okay. So there is no following question, Professor. So I will read another question, Professor.
Yeah.
It's come from Ahmad Tri from Computer Engineering. He has some question. Can this method used in stock market to read the graphic pattern in market share? If possible, can you give the example?
Yeah, I provide example. You can use two different way. The first way is just see the graphic. I mean, as an image. You can compare image of two fluctuations from two different stock markets and compare them. And another technique that you may be able to use is consider the two fluctuations from two different markets as a time series sequence. Then, so you can use a similarity measure to compare them. If the one that you want to use is about using graph or image of the fluctuations of stock markets, then you need to have a two-dimensional similarity measure that is often used in image processing. Yeah, but still I can say that, yeah, it's able to handle the fluctuation and compare and analyze the behavior of patterns in the stock markets using similarity measure.
Okay. How about it, Ahmad? Okay. That's enough, Professor. Thank you.
Thank you.
Another question is come from Ridwan Anwar Fauzan. Hello, Professor. My name is Ridwan from UNIKOM. I have question. Does the similarity measure can use for recommendation system? For example, recommendation system between relevant item to user preference in online shopping.
Yeah, definitely. One of the application of similarity measure is in recommender system. So you have a profile of your customers, and a new customers come to service. You can see the past behavior of the new customer and compare the behavior of this new customer with the one that you have in the database, and then choose the right one and recommend the items to the customer. Yeah, it has plenty of application in recommender system.
Okay.
So
that's
it means
the
that
answer.
Yeah, it means that your participants are very interested in the subject. So I'm very happy about that.
Okay. Okay, thank you. Another question, Professor, is come from Andika Bahari.
Yeah.
The question is, after we apply time wrapping, does the mean we have narrowed down the choices to pick one of the similarity function? Because I'm assuming that we have aligned the time between two sequences. Thus, the time property has disappeared.
Yeah, the time, the time property is not disappeared, but as I said, for the two samples, Ali and Ali, so still they have correlation in time, but you say that some samples are warped, means that some samples are repeated several times, several consecutive times. So in this case, we cannot say that the relevancy is disappeared. Still they are relevant, but stretched. The relevancy is stretched.
Okay. Oh, there is plenty question, Professor. Is that okay?
Okay. I have a time restriction here today. I have another meeting. Sorry about that. Maybe we can, arrange another presentation, inshallah, in future, and to discuss more about the detail for similarity measure, Mr. Hanhan.
Yes. So I think we should end the session, or you can still have one or two questions.
Yeah, one or two questions is okay.
Okay. I will choose the question. It's from Muhammad Julhaki. Assalamualaikum, Professor. I am Muhammad Julhaki. I have question. How can we use similarity measure method to improve data analysis in identifying pattern or relationship that exist between two different data sequence on a time scale?
Yeah, but I need to see the data. I cannot recommend anything.
Yes, of course.
Just telling me about the application, I cannot see anything. I need to see the data. Sorry.
Okay. Another question, Professor. Maybe this is the last question from Reza Kurnia. In case of speech to text, time alignment of different speech is the core problem for distance measurement in speech recognition. Small shift result in wrong identification. Can dynamic time wrapping solve this problem, and what is the level of accuracy?
Yeah, definitely. Time warping can be used to handle a situation. And the restriction is about the window, as I explained in my presentation. If the window length is very large, then many different speech would be very similar. To have more accurate data, if you want to have more accurate performance, you need to be careful about choosing window of dynamic time warping. Yeah, this is the key points to consider in using dynamic time warping.
Yes. Yeah, actually, there is a lot of question in the chat, Professor, but because we have limited by time.
Sorry about that, and thank you. Yeah, thank you.
Yes, and before we leaving, Professor, so
thank you.
Let's do a photo session first.
Okay, thank you, Mr. Hanhan, and thank you to UNIKOM University, especially the rector of the university. Please say my regard to the rector. It was really my great pleasure to participate in the presentation, and I am very happy to hear that many of your participants had interested in the subject. As I had in my presentation, considering similarity measure is an important issue in engineering field. It can be very helpful to design the system simply. It can help us to design the system in a straightforward way. Inshallah, in another time, if your participants are interested, we can have another presentation, maybe in webinar or in face-to-face, inshallah, in Bandung.
Inshallah. The pleasure is on us, Professor. So for the photo session, we need for documentation, Professor. And audience, please activate your camera. We will take the photo session for this event. So the audience, please activate your camera. Okay. Everyone? Okay. Okay, please everyone activate your camera. Okay, for the first slide, yeah, we have so many participants, so we need 11 slides for the photo session. First slide, please. Okay. Then second slide. Okay, next. Third slide.
Or I can take off my glasses.
Oh, okay. 4. Okay. 5. 6. 7. Okay, next, and last 11 slide. Okay, that's enough.
Okay.
Okay, thank you, Professor. I hope we will meet again in another event. So,
Inshallah.
Thank you very much.
My pleasure.
See you. Yes, see you
Inshallah.
in next
See you.
UNIKOM Light Series. Thank you, everyone.
Inshallah. Thank
I
you.
will close. Yes, I will close this event. Assalamualaikum warahmatullahi wabarakatuh.
Assalamu alaikum. Assalamu alaikum.